Here is another problem on how to form a PDE by elimination of the arbitrary function. We have to form a PDE from z is equal to exponential to the power of as plus by multiplied by the function of as minus by. How are we going to form a PDE from this following given problem? It means for us to form a PDE by elimination of the arbitrary function, we have to differentiate the z with respect to x partially, then we differentiate the same z with respect to y partially. So from y we compare what we can do to remove the arbitrary function. Z is equal to EAS plus BY f of AS minus BY. I can name this one as equation 1. So the step is what? To differentiate partially. Differentiating partially with respect to x in equation 1. So it means I'm going to differentiate z with respect to x. If I differentiate z with respect to x, I'm going to have partial z over partial s, or the z over the x. Z is equal to this what we are given. This is a product. We have exponential to the power of as plus by multiplied to what? Function of what? F of as minus by. It means I'm going to consider this is a product. I'm going to consider this as first one, consider this one as second one. This given equation, I'm going to take this one first, EAS plus BY. Then I now differentiate this one with respect to x. Then I will not take this one first. Then now differentiate this one with respect to x. It's a product, so I'm going to use a product rule to solve this. I've taken EAS plus BY. So let us differentiate f of AS minus BY with respect to x. Remember that whenever we are differentiating with this function, it means we are going to differentiate what is inside the bracket, AS minus BY. You can see that I'm going to differentiate with respect to x here. If I differentiate x here, I'm going to have 1 multiplied by a, I'm going to have a. It means a is what? When I differentiate the bracket is a, then it's going to multiply everything. But when I differentiate f, I'm going to differentiate f as well as f. If I differentiate f, I'm going to have f prime. So from there, I'm going to have a f prime, then multiply by everything, as minus by. It means if I want to solve this one, differentiate this one with respect to x, I'm going to differentiate what's inside the bracket with respect to x, which is a. By is not related to x, so it will be considered as what? Constant. And when we differentiate the constant, I'm going to have 0. So that's why we have a minus a, x is 1 times a minus 0 a. Then I'm going to differentiate f. So when I'm differentiating f with product of this, I'm going to have f point multiply what is inside the bracket plus I will not take this one f of, I will consider this as minus by, then multiply by this one with respect to x. Remember that whenever we are differentiating with exponential, we only differentiate the power, then multiply by everything. So we are differentiating with respect to x, we have to differentiate only with respect to given x. X is here, I'm going to consider as s as 1 times a will be a plus by is a constant, it's not related to s, is 0. So there is a plus 0 is a. So a is going to multiply everything. I'm going to have a multiplied by as plus by. So what is my next step? Remember that our notation for partial z partial s is p. So here is p is equal to what? I'm going to have, I can take this one a, this a f prime, this is a product. I can take as plus by, then multiply by what? F prime as minus by. I take a out here. This a is affecting this, it's also affecting this. It means af prime. So a is outside, then this. I can write this one a at this as well. This is empty. Plus a exponential as plus by, then f of what? As minus by. I can consider this as equation 2. So let us differentiate equation 1 with respect to y. So there is z all over what? There y is equal to as plus by. I'm going to take this one. Now differentiate this one with respect to y. So in this case, I'm going to consider y not x. So this is x, it will be 0 minus by. I'm going to differentiate y. I'm going to have 1. 1 times minus b, I'm going to have minus b. The reason why we're having minus by is I'm going to take minus b, differentiate y. If I differentiate y, I'm going to have 1 plus take y, differentiate minus b. Minus b is 0, it's a constant. So that's why minus b times 1 minus b plus 0 can say our answer is minus b. That's why I'm having minus b. So if I differentiate y, I'm going to have 1. Just multiply it with what? Minus b. So I'm going to have what? Minus. Multiply by minus b. Then differentiate f. I'm going to have f prime. As minus by. Plus, let us take this f of as minus by. This is a product. Now differentiate this with respect to y. So I'm going to consider y here. If I differentiate y, I'm going to have b. Here will be 0. There is b e. Remember eax. Eax plus what? By. So our notation for the z over the y is q. So eax plus by. I can take minus b outside here. Then multiply by what? I've taken minus b to multiply this one. F prime as minus by. So I want the function to stand alone. That's why I'm taking what is multiplying by that function to the next, plus f of ax minus by as plus by, then f of what? As minus by. I can name this one equation 3. Now what are we going to do? Look equation 2 and equation 3. How can I eliminate the arbitrary function from this case? Variable common in equation 2 and there's a variable common in equation 3. If you look at that equation 2, a is there, a is there. I can easily factorize a outside. So in equation 2, I have p is equal to a. A is common between them. Let me take a outside. Eas plus by f prime as minus by plus a is there, a is outside. I'm going to have eas plus by f of what? As minus by. Call this one as equation 4. Then equation 5 as q. What's our 5? Our 5 is equation 3. In equation 3, I can factorize b outside, like taking the common terms. Minus b. Here is minus b. Eas plus by f prime of as minus by plus, what do we have here? I have b here. Minus times plus is minus. So this one is plus. So I'm not going to have plus sign. I'm going to have minus sign. Minus times minus, I'm going to have plus. So it means that minus eas plus by f of what? As minus by. Here is equation 5. Since we have solved this, what are we going to do next is, if you check equation 4 and 5, there's no way we can eliminate the arbitrary function, but there's something common between them in that function. We have eas plus by f of as minus by. This one and this, they are common, and also is related to what? Z, given function as z. But how are we going to eliminate aeas plus by f prime of this and this? How are we going to eliminate this one? This one is a and this one is what? Is minus b. This one is a, this one is minus b. But what I can do in p and q here, in equation 4 and 5 here, to multiply equation 4 by b, why to multiply equation 5 by what? A. So that p is going to have what? Ab. Equation 4 is going to have what? Ab. And equation q is going to have what? Minus ab. Equation 4 by, this is equation 4 by b. So if you multiply equation 4 by p, what are we going to have? Equation 4, we have p here. If you multiply p by b, we are going to have bp. Bp is equal to, we have a outside already. If a is going to open this bracket, we are going to have a exponential as plus by f prime as minus by. Remember that we are multiplying this one with b, we are going to have what? Ab. So we are going to have ab exponential as plus by f prime as minus by, close the bracket, plus this a also is going to multiply this one as well. So if a multiply all this one, we are going to have a with this. Then we are using b to multiply as well. So we are going to have ab as well. Plus ab exponential as plus by f of as minus by. The next step is to multiply equation 5 by what? By a. Multiply equation 5 by a. So what are we going to have? This is equation 5. If I use b to open this bracket, minus b to open this bracket, I'm going to have minus b Since we are multiplying a, so I'm going to have minus ab, and I have q outside here, so I'm using a, so I'm going to have aq. Aq is equal to, this minus b is going to open this bracket, followed by what? By a, so I'm going to have minus ba or minus ab, minus ab, then exponential ax plus by f prime of as minus by. Minus b is outside there. Minus b is going to open this bracket as well. I'm going to have plus b. Multiplied by a, I'm going to have ab plus ab exponential as plus by f of what? As minus by. This one will be equation 7. So what are we going to do next? If you consider equation 6 as 7, there is something similar to each other. You can see in equation 6, we can find ab exponential as plus by f of as minus by, as well as this. You can find this one in both. But in the first term, in the second term, let's say this one is first term, second term. The second term of this one, minus ab is here, ab is here. So we can easily eliminate this one from this. But we are going to add what? Equation 6 by equation 7. This is positive and this is negative. If you add positive with negative, if they are the same, it's going to cancel out this. It's going to cancel out each other. So we can easily add positive with what? Negative, so that what? It's able to cancel out each other. Add equation 6 by equation 7. So we add equation 6 by equation 7. What are we going to have? We have BP plus what? Equation, this one plus this plus AQ, followed by this one. Let us add this one with this. I'm taking the first term, add it with the first term for equation 6 and 7. The second term, add it with what? Second term in equation 7. While the third term in equation 6, add it to what? Third term in equation 7. So the second term, AB exponential AX plus BY f prime AX minus BY. Then plus is addition. The sign for addition is plus. Then plus minus AB AX plus BY f prime AX minus BY. Then followed by what? The last term. What is it? AB exponential AX plus BY f of AX minus BY. Then add it to this plus AB exponential AX plus BY f of what? AX minus BY. So if we add this BP plus AQ, then we have AB exponential AX plus BY f prime AX minus BY. If you add this one with this is plus. Plus times minus, it will be minus. So here will be what? Minus. So I'm going to have AB exponential AX plus BY f prime AX minus BY minus AB exponential AX plus BY f prime AX minus BY. Then plus all this AB exponential AX plus BY f AX minus BY plus the last term AB exponential AX plus BY f of AX minus BY. So let us add this one minus this, and it's going to cancel out. They are the same. So this is positive, this is negative. It's going to cancel out. It's going to cancel out. So I'll be left with BP plus AQ is equal to AB exponential is there. AB exponential is there. If I add it together, I'm going to have 2AB. 2AB exponential AX plus BY f of AX minus BY. The coefficient of AB exponential AX plus BY f prime of AX minus BY is 1 here. So this one is also 1. 1 plus 1 is 2. So I'm going to have 2AB since they are the same thing. So what I'm going to do next, remember that if you look at our relation that we have been given there, you can find that exponential AX plus BY f of AX minus BY is what? Is Z. Since Z is equal to what? AB exponential AX plus BY f of AX minus BY. So for us to eliminate that function, So it means we are going to replace that what Z, because Z give us all these things. So we are going to have BP. So we are going to have BP plus AQ is equal to what? 2AB. This is Z, which is what? Which is the required PDE. Which is the required PDE. PDE. So it means we have eliminated the what? The arbitrary function from this given relation, and our newly partial differential equation is what? BP plus AQ is equal to what? 2ABZ, which is the required PDE. It means we have solved by elimination of the arbitrary function. So that's how we do arbitrary function. You can say from here, since when we get here we have F, so we have to find something that to replace that F. Since our Z is what? That give us that function. That give us the function of exponential AS plus BY multiplied by the function of AS minus BY. So in that case, we are going to replace it as Z. So I have solved this problem whereby we get our partial differential equation as BP plus AQ is equal to what? 2ABZ. I hope you found it interesting, and don't forget to share, like and comment. Thanks for watching.